Okay. All right. Jesus is my Lord and Savior, and Trump is second to none. In the name of Trump, we start this lecture. Oh, there you go. Damn it! I don't know how to. All right. So we're gonna look at a partial derivative in calculus 3. We have z equal f of x y. The graph is the surface, right? So you can stand on the surface and walk in the walk in the positive x direction or positive y direction, whatever it is. We're looking at that part, and we want it to be like smooth curve. Like if it's like rigid, it acts all funny, and trying to find the derivative, trying to find the plane that barely touches that surface, it gets very difficult because you're not going to find one plane. And walk positive x direction or the positive y direction. So let's look at the definition of that. Can you guys see green? The partial derivative with respect to x at the point x naught y naught is dx is limit as h goes to 0 of f of x naught plus h. You guys remember that, right? From your calculus 1. So this is to the x, and we're going to do one for the y. Definition: the partial derivative of with respect to y at the point x naught y naught is limit as h goes to 0 of f of x naught. This is the part, y plus h. We're just looking at the y part. Now, Are we gonna do this long way of doing that derivative quotient rule? No, we could just go directly into that problem. So let's look at it. Can you see it? H. Are you talking about this H? H. Because at the bottom is H2. You can call it N, but all right. Find the values of df, dx, and dy at the point 4, -5 if f of x, y equal x squared plus 3xy plus y minus 1. Okay? So to find df dx, we treat, remember a partial derivative, we treat y as a constant. And sheet with respect to x df dx. What's the function? It's pretty easy, right? 2x, oh sorry, let me write that in. X squared plus 3xy plus y minus 1. This becomes what? 2x plus 3y. And we're going to do that at the point 4, -5. And that gives us what, guys? -7. Can you guys do df dy? And I want you to get the number for that. Partial derivative is not that hard. What happened to Miss Yama? You guys don't hang out? Just outside the class? What? You guys are young. You guys don't need to worry about COVID-19. Wait, haven't you heard Trump? Young people won't get affected by it. He's the president. You gotta listen to the president. You telling me that you don't listen to your president? Ooh, you're such a rebellion. Wow, you're so cool. You don't listen to the grown-ups. All right, ready? What's the answer for the other one? What is it, guys? What's the derivative of this would be what? 3x plus 1, right? And what would that give you? 13. Yep. All right. Let's try another one. Ready? Find df dy as a function if f of x, y what is it, guys? What's the answer? Is it a hard one, guys? As a product rule, then you have a chain rule. First one, you will get what? Sine of xy plus y times, what's the derivative of inside? The derivative of this, oh, right over here. What is it? Derivative of outside times the derivative of inside, right? What's the derivative of outside? Cosine of xy. And then what's the times the derivative of inside? What's the derivative of inside? X. Is that correct? Let me see. Yep. My final answer is what? Sine of xy plus xy cosine of xy. Yeah? Good. Here's another symbol to write this this one right over here. You could write it as f of y in this case. The partial one? Oh yeah, yeah, quotient, yeah. You could the other way of writing dx of f would be, I think engineers use this one, right? I don't know. I've never taken any ME classes. ME students?
Online, they usually use like the apostrophe.
Apostrophe, okay, they do this.
Time derivative, they'll use the dots on top.
Oh, okay, yeah.
So I don't like them because I like to use my dx, dt, or whatever, so I can do that.
I think it has dot came to be due to the programming. It's just how they wrote books. I don't know. Should take the history.
Like a dot on top for the first derivative and like 2 dots for the second.
Yeah. I bet it's the Germans. It's the Germans. Anything wrong in this world, blame it on the Germans.
In my book, they call it the Newtonian notation.
Is it Newtonian? Isaac Newton used that?
Yeah, the dot.
Huh, I'm gonna read that up on it. Damn it.
I don't know if it's like actually what he did.
No, he never used he never used any shortcut. His stuff was very hard, long. He did crazy stuff. I gotta look it up. Maybe it could be that. Anyway, I still like to blame it on the Germans because of the soccer team. And World War II. And Trump, because Trump came from Germany. Did you guys know that? So. Well, yeah, you don't understand. Like, I contradict myself every 5 minutes. It's like religion. You open up any science fiction book, and within 5 minutes, they break the rule of it. What? Fair. Alrighty then. Let's look at this one. Fine. Ooh. Alrighty then. You guys are done? Let's look at it. We use quotient rule. You got what? 0? It doesn't matter. And then minus the derivative of that would give you what? What's the derivative of cosine? Negative sine of x, right? And then y plus cosine of x squared, which is just sine of x over. Okay. Did I miss something? Did I miss something? I feel like I missed something. Oh yeah, I forgot the 2y, yeah. Yeah. Okay. The derivative of that in respect to y, I get 2y plus cosine of x plus 2y. Oh, it's just 1. Y plus cosine of x. Please don't distribute that square inside that. If you do, you get automatic 0.
What if it'll simplify something out of the numerator?
Oh yeah, you can, but you're talking about, you could expand it out if you want to, but you just don't write it like this. That's what I mean by that. Yeah, that's what I'm saying. Yeah. This gives us just 4y plus 2 cosine of x. Now, you might think that, oh, what about all this crazy trig formulas and all that? Don't worry about that. We're not going to do none of those crazy trig formulas. You know, those half angle, double angle, power reducing and all those? Yeah. Princess is saying you're learning that. That's right. Yeah. I remember I was using SPS. What version SPS is it right now? I started using when it was like infancy, like the version 2 or something like that.
What is SPS?
SPS is like MATLAB. Yeah, but SPS is even more industry oriented. Like if you know, like those engineers, you know how to do SPSS, which is pretty. If you're engineers, it's not that difficult. Just 1 semester of classes. Basically, it just helps. It's a program that makes your competition so much easy. So you know this, you'll get a good job in the field. SPS, I think SPS now is better than MATLAB. I don't know.
I like MATLAB when like we started using like the exponential function to represent vectors. Like,
yeah.
You do it to imaginary numbers and something, and then we'll like do the
when I used it, the computer used to be so slow. We would wait. Now computer's so fast. All right. So fine. DZ in terms of, okay. Oh, all right, let's do that. In this case, you cannot do this, guys. That's big no-no. So let's look at it. Ready? Dx of yz minus dx of natural log of z equal x plus y we'll just do z dz of x plus y. Okay, first one, that one is just gonna be y. That one you're gonna get, sorry, you still have dx, sorry, d, and then you have z dx, dz dx, dz dx, and then there's no z, this right over here. Yeah, we're doing in respect of x, and this is a constant number, so which is just gonna be 1, and this is gonna be 0. So let me write it down. What just happened? We differentiate we differentiate both sides. Technically, this is what I want you to look at, though. This is technically dx over dx, and this is technically dy over dx, right? So you're taking derivative in respect of x, so therefore, what's the derivative of x is 1. But you're taking derivative of y in respect of x, and in this case, x is the variable, whereas y is the constant. So what's the derivative? Like, it really doesn't matter. The derivative constant will be 0. Who came up with this?
holding like the variable constant.
I, I'm like when I studied, I looked at it like this, and that's what it essentially means. I should have written a paper on that. Oh well.
I think it's pretty cool that you can do that. Just hold it constant.
Yeah, you could write that. You could write a. Actually, if you're a mathematics degree, you should write a paper on that. No, it's just a semester long. Both sides of the equation with respect to x holding y constant and treating z as a differentiate and z as a differentiate function of x. So I already had the answers. So y dz dx plus minus 1 over z dz dx equal 1. So dz over dx equal what? 1 over y minus 1 over z. And you could simplify that. This will become zy minus 1 over z. This essentially becomes, we don't like to have fractions over fractions.
Can I see the original function?
Oh yeah.
So we can tell what's the constant
by giving this to you. So what you're doing is you're taking the derivative of z, right, in respect to x. So z as a function that you can differentiate. In that case, y becomes a constant. So hence, another way of looking at this way, dx over dx, dz over dx, dy over dx, y is a constant. So what should I have for dinner? Oh, found even better taco spot. It's the best taco spot in town. So good. It's a food truck over the weekend. But it's next to a gay club, which is standing right next to a place where they give a free HIV testing. I'm like, why are they giving out free HIV testing over here? Why not other places? So, yeah.
I got set up at work one time. Like, there's a department where they do all the testing and stuff, HIV traffic, and we send out blood draw trays and stuff to collect locations. They sent me to this one place, and they didn't tell me what it was. So I go in there, and it's a gay spot. Like,
where is it? Because I like going to the gay clubs. They're the best club you want to go to.
I don't even remember. It was like on Sahara in Maryland or something over there.
Sahara and no, it's like Fruit Loop District, right? It's on Paradise.
Yeah, I don't know. It was like you have to go in, like it's like a block, and you have to go behind to go inside.
Yeah, they have all the gay clubs and bars and everything over there. Yeah, the drinks are the cheapest in town too over there. Sam Smith was there. What is it, like 8-9 months ago? And he made out with everybody at that bar. There's a video of it. You guys know the singer Sam Smith? The singer, yeah. He made out with everybody. I was like, what? He was there. It's called the Quads. Just in case if you're growing up and you want to have like wild night, go there. You'll save more money. Right, Rin? What is it? 6 years from now, you will turn 21? When? The plane.
You can hold our age constant like a variable.
The sad thing about it is, is it differentiable or not? If it is, she ceased to exist. The the plane x equal 1 intersect the paraboloid. Z equal x squared plus y squared. So if you graph this z equal x squared plus y squared, let me do my best to try to show it what it would look like. Do you guys see this paraboloid? That's z equal x squared plus y squared. Do you guys see it? So at 1, you draw a plane. If you draw the plane at 1, and you cut that section out, do you see what it looks like? It looks like a parabola, right? It looks like a parabola.
On your graphs, which leg do you use as
X, Y, Z.
Some of the books, they switch it up. Then it's like confusing.
And not in the math book, not that I know of. I've seen it. They do it kind of like this. Weird way of doing that. I don't know. But those are 3D graphing. I don't know.
Pearson had somewhere the Y and the X on there with the
X and Y, really? No, maybe they're showing it a different part of the graph. So if I would have drawn it, whereas Z is sticking out this way, that's Y, X, right? Then you just get this type of parabola. So by rotating it, you could see the graph better. So that's probably why. All right, here's the question. Find the slope of the tangent to the parabola at 1, 2, 5. Now that's where we get to see what's happening over here. All right, so let's look at an answer. The slope is the value of the partial derivative dy at 1, 2. So let's look at it. dz dy at 1, 2. What would that equal? It would just equal 2y 1, 2, and it just has 2, which is 2 times 2 is 4. And that's it. 1, 2, and then 1, 2, 3, 4, 5. So I want to know the slope. Yeah, what it would look like. Okay. And that kind of makes sense. Yeah, it's a parabola. What's happening on the slope? Now, second order of partial derivative, which is pretty easy. Second order of the partial derivative. Okay. Here's another way of writing that. There are all these different ways of doing that. df dx plus y equal x. That's pretty easy though. In this case, you get what? Cosine of y plus y e to the x, right? Now, how do we do the next? Oh, let's do one more. df dy. What's df dy? In this case, we would get negative x sine of y plus e to the x. So we got these two done, right? Now, how do we do next part? D square f of dy dx. What would that be? Another way of looking at what that be is df dx. And we already did df dx, right? Yeah. So we're doing a second partial derivative. First one, you do it in respect to x, then you do it in respect to y. Okay? Now, something interesting happens over here. Cosine of y plus y e to the x. And the derivative of that would equal to what? Negative sine of y plus e to the y. Right? Now, what if I change the order and do it in this fashion? dx dy. And df dy is what? To the x, and this would give me, is that correct? X sine of y e to the x, right? Yeah, okay, good. So now derivative of that would be negative sine of y plus e to the x. Oh my god, look at that. It's the same. So dy dx, the order really doesn't matter. You'll get the same answer. Yeah. You're talking about this one?
Yeah.
I'm taking right over here, y e to the x. I'm taking the derivative of this in respect to y. So what's the derivative of y? Oh, is that x? Sorry. It should be x. Sorry. Yeah. Good catch, Jordy.
If you did it 2 times with holding the same one constant, you're gonna get the same function. Like if you did with respect to x, then with respect to x.
We're going to do it right now.
Oh, it doesn't give you the same answer.
No. So let's do d square of d x square. Let's look at that. I still haven't, you guys haven't helped me out yet. What should I have for dinner? What, tonight? No, I'm going to get hungry.
Just pure alcohol.
No. Pure alcohol is so nasty. And I'm not 14. You need to have fine alcohol. You cannot drink those pop-off or what is this? The crappy tequila smells like... Have you ever smelled a newly printed book from a factory which is not well regulated? Okay, you don't know what I'm talking about then. Yeah, if you ever get a book, it's printed on a not so well regulated. So they will use weird chemicals. And if you open that book, it smells like those type of tequila. Bad tequila, yeah.
All the way back.
What? So...
But you need to drink some of that crappy stuff so you appreciate more of it.
I've drank it, those crappy stuff. Ew, no. Oh, my Lord, have mercy. Why? It's like, what is in it, by the way?
If you mix it with beer, it's actually like a lemon one.
Ew, beer itself is nasty
I
too.
swear to God, it's like taking you know, at McDonald's, you take the hot and spicy and the McDouble.
Yeah.
Both mediocre, but you put them together and it's like a godsend.
Really? What is it? What do you do in McDonald's? You get spicy?
Hot and spicy and then a McDouble. And you rip the McDouble open, slap the chicken.
Never thought about that.
Swear to God.
I just had the spicy chicken McNugget yesterday.
Oh.
I should do that tonight, man.
And there you go.
Yeah, there you go. Thank you. All right. Now we take the derivative in respect to x gives us what? Y e to the x. Oh, forgot to plug in the battery. No, done that. Okay, so where is df? So d y f. And the derivative of that I'm doing in respect to y, would that be negative cosine of y? There you go, done. Okay, so let's try this problem. Oh, this is x. Nope, this is y. Let me make sure. Yes. All right, kids. All right, ready, kids? So, tells us to differentiate first with respect to y, then with respect to x. So dw dx gives us what? That's easy, y. And and we're just taking the derivative of this, dy of y, which is just 1. That problem was super easy, guys.
So even when you do like a different variable, still follow the second order of it.
Yeah.
That's all.
Even though in this case, order really doesn't matter because d square, dw, dx, dy, if you would have done dx and dy, your life would have been harder, but you would have got the same answer.
I get that part. But I was confused like because it has a second derivative. I don't know if like take two derivatives and then take the two derivatives.
No. D squared means it's, you have total two derivatives happening. So another way of looking at that is like dw, d, like you're doing d of dw. It's kind of like get a way of explaining it. Okay. All right, let's try this one, kids. Yx, yz. It's not that difficult, guys. So you start with what? Fy. What's Fy? Negative 4xyz plus x squared, right? Then we do Fyx. Now we take a derivative in respect of x for yz plus 2x. Then we do Fyxy. This gives us negative